And here we go with section 7.3, confidence intervals for standard deviation. Well, for standard deviation, we need a whole new critical value. Ta-da! Here's chi-squared. So the CHI is pronounced chi, and it's like a little curly x, which is then squared. So chi-squared, and here's the formula for it. So this is one of the few formulas that's not in the calculator, so we will need to calculate this ourselves. But luckily, it's pretty small. It's just the sample size minus 1, the sample standard deviation, and then the squared, and then the overall standard deviation squared. So before we move on, there's a couple of things to know about the chi-squared distribution. First of all, it is skewed. So that means that when you look up a critical value on the left, it's not the same as the one on the right. So the graph is not symmetric. Also, there are no negative values. Because of these squares, the squares would get rid of any negatives, so there's no negatives. And we're going to be using table A4 to look up the critical values. As we saw before in table A3, degrees of freedom is n minus 1. So now, on to the next, or the first example, excuse me. 95% level of confidence, the sample size is 32, and all we're going to do is look up the critical values. So here's table A4. On table A4, notice that I've paired these up. Well, first of all, I drew a line down the middle because chi-squared right will be on the right side of the table, and chi-squared left will be the values on the left side of the table. And also they get paired, so this 0.10 together with the 0.90 equals 100, then 0.05 gets paired with 0.95, etc. So having these little red lines at the top help me pair them up and find the critical values faster. So I would suggest that you do that too. Okay, first of all, write down the information. So if n equals 32, degrees of freedom is 31. Since we're using 95% level of confidence, 1 minus 0.95 is alpha equals 0.05, and then cut that in half. So when you see this 0.025, you'd find that over here on the right, 0.025. So we're going to be using that column. And then you just follow the little red line for that one. It's over here. So then we'll use this column with 0.975 at the top. And then you look on the side and there is no 31. So whenever these tables don't have what you're looking for, just use whatever's closest. The closest they have is 30. So that means on the right, the critical value chi-squared right equals 46.979, and on the left it's 16.791. And that's it for that example. We're just practicing using the table. Now, how do you make the confidence interval? So this is the formula. So you've got n minus 1. This would be the sample standard deviation, which would be given. And then these are our two friends from table A4. Chi-squared left is on the right, and chi-squared right is on the left. That's not a typo. That's how it actually works. Because chi-squared right is the bigger number, when you divide by a bigger number, it gives you a smaller answer. So the smaller answer will be on the left, the bigger answer will be on the right. If the question says make the confidence interval for variance, you're finished. That's it. If it says the make a confidence interval for the standard deviation, then in order to get rid of this square, you would need to square root both sides of the inequality, and then you'd be finished. Okay, next example. Suppose that S is equal to 9.4, N is equal to 42. Use the 98% confidence level. So first of all, write down the given information. And because we're using 98%, that means alpha equals 0.02. And then cut that in half. So bring up the table, and then degrees of freedom is 41, but there is no 41, so use 40, that's the closest. And then this is 0.01, so use 0.01 over here on the right. And then follow the red line for that one, and it's going to go with 0.99. So chi-squared left is a 22.164. Chi-squared right, a 63.691. All right, now I'm done with the table. And now I'll do that little formula. And like I said, unfortunately, this is not in the calculator, so you need to set this up yourself. N minus 1, the s gets squared, and then here's where you put chi-squared right on the left and chi-squared left on the right. Then just type that into a calculator and take the square root of each answer. And we end up with the standard deviation is somewhere between this 7.5 and 12.785. Well, that was so fun. I think I want to do another one. So this one comes with a little more of a story. So in calculus class, there's n equals 39 people. The average doesn't matter because we're not talking about average, we're talking about standard deviation. So standard deviation equals 10.6. But standard deviation should be 15. So the idea is by the end of the semester, is it possible that their standard deviation would be 15? So make a confidence interval, and at the end, see if 15 lands in that interval. If it does, it's possible. So here's the given information, n equals 39. I've got the s, and since I'm using 95% level of confidence, then use 0.05. Hey, just by the way, if this percent is ever not given, then use 95% as a default. That goes for now until the end of the semester. Okay, next up. Degrees of freedom is 39 minus 1. When you take the alpha and cut it in half, it's 0.025. And now we're ready for the table. So using 0.025 would be this column right here, and then go down to right here. So again, there is no degrees of freedom of 38, so over here use 40. And then this 0.25 connects with this one. So move down to right here. So there are the two critical values. Chi-squared left, 24.433, and chi-squared right, 59.342. And believe it or not, we are almost done. So set up the little formula. Hey, wait a second. Don't jump to the answer. N minus 1, the s is squared, and then chi-squared right goes on the left. The top is the same, but on the right, you take chi-squared left and put that on the right. So you divide those and then take the square root, and at the end, the standard deviation is between these two numbers. The last thing was, does 15 seem possible? Well, it says it's between 8.4 and 13.2, so no, the 15 does not seem possible. And I can be 95% confident when I say no, it's not possible. All right, that's it. I'll see you in Chapter 8.